Hi, I'm Hannah. I'm a tutor at Sky Academy. We're in the topic of statistical analysis within the Year 11 standard course. We're looking at relative frequency and probability, which comes under MSS2. So this is our final video in this topic, and we're going to talk about real life examples because exams and questions love to apply your knowledge to real life examples rather than just focus on the mathematical concepts on how to do things. They like to apply that knowledge to real life examples. So for example, we're going to have a look at this question which talks about blood types. So it won't specifically ask for the expected frequency or anything to do with probability, but that's essentially what we're doing, and we're going to use our knowledge of that to apply it to this question. So the question says, the table opposite shows the number of males and females living in New South Wales. So we have 3.8 million males and we have 3.9 million females. So now it says use the column graph, which is down here for us, and the table to answer these questions. So question A says, how many males in New South Wales have the blood type B positive? So if we have a look at our column graph here, B positive is located here, and it has a frequency of 8%. So we know that the frequency of B positive in Australia is 8%. So if we use this information and the number of people who are males in New South Wales and we times them together, we will get the expected amount of males in New South Wales who have the blood type B positive. So essentially what we're finding is our expected frequency. So it hasn't specified to ask, the question hasn't specified the expected frequency, but we know from our knowledge that this is essentially what we're doing. We're finding the number of people, of males in New South Wales, timesing it by our frequency or our probability of people who are going to have B positive. And so then we'll find the expected frequency of people who will have B positive, who are males in New South Wales. So following the formula, the expected frequency formula, we have the number of the total amount of people. So that's 3.8 million. So that's 3.8 million people. And we're going to times that by the probability, which is 8%. And that's going to give us a expected frequency of 304,000 people. So we have just found the expected frequency of males in New South Wales who have the blood type B positive. So we can expect that out of 3.8 million people, we can expect that this many will have blood type B positive. So now let's have a look at question B. How many females in New South Wales have blood type O negative? So if we have a look at our column graph again, we need to find O negative, and O negative is located here with 9%. So if we times the females in New South Wales, which is 3.9 million, times by 9%, it will give us the expected frequency, or how many females in New South Wales will have blood type O negative. So if we put that into the calculator, we should get an answer of 351,000. So we're just using the same formula as we did for question A in question B, but we're just changing out because we're using different variables or data points. And finally, how many people in New South Wales have blood type A positive? So Firstly, we'll go to our column graph and we'll go to A positive, which is here with 31%. And then we're trying to find the general amount of people in New South Wales who have A positive. So we're not separating between females and males. We want the total amount of people. So we're going to use 7.7 million. So I'm going to do that down here. So it's 7.7 million. We know that when we are calculating millions, we have one number out the front followed by 6 numbers behind. So if it's 7.7, it'll be 7 and then 7 and then 5 numbers to make us up to the 6. So then we have one number and then 6. 1, 2, 3, 4, 5, 6. So that's 7.7 million times it by 31%. And it's going to give us a really big number this time. 7, 7, 1, 2, 1, 2, 3 times by 31%. It's going to give us 2,387,000. So 2,387,000. So that's how we can do real life examples relating to relative frequency and probability. Although the question didn't specifically ask for it, we're going to use our knowledge to apply it to this real life example. So we had the probability that probably 8% of the population will have B positive. And then if we times it by the number of people that we want, we can get the expected frequency, or how many people we can expect to have B positive.